as I mentioned, I'll have some USB ports in there. Therefore, I have this small module over here. We have two standard Type A USB ports. It's a small device pre-built that you can buy anywhere. I have some M2 standoffs already in place with the according M2 screws on the bottom. The nuts on top are glued in place because they come loose quite often, so I decided to glue them in place. And this will provide a power, and that's also the reason we have these two ports over here. Now again, I have to feed power from here to these top two USB ports, but I'm not intending to use all ports at the same time. This module over here is a buck converter. You can feed in 6 to 26 volt DC, and you get 5.2 volt at maximum 3 amp output. And this is plenty for anything that I'm going to do with the USB portion of this battery pack. Next off, we have the heart of this battery pack slash power bank, which is this over here. This is a 2S4P configuration, which means we have 2 cells in series and 4 cells in parallel. If we take a look over here, these 4 cells have the negative connected to this nickel strip, and these 4 cells from here to here, all the positives. And then we have the split main positive and main negative over here. Now let me just quickly go over how this is constructed and why it looks how it looks. But we will actually install another 2 cells into there, which are these ones over here. Now please note that I did not measure the capacitance of these cells. These blue ones and these 2 brown ones are the same type. These were actually blue ones, but they had badly damaged insulation. And at that time I didn't think I would use these battery holders, and therefore I replaced the heat shrink. But using the battery holders we have a bit more safety, so this was not as necessary, but it's nice, so it looks a bit better. Now these 6 cells are the same type. They are supposed to have 2650 milliamp hours if they are not damaged. At the time of building this battery pack I wasn't really concerned about it. Now in hindsight it would be better to actually rate the cells and match them more perfectly. Then we have these other 2 cells which are also the same capacitance. The only actually pre-capacity rated cells are these ones over here, because right now I am currently trying to measure capacitance of a whole bunch of cells. This is the battery pack, and we will build another 2S battery that will connect it in parallel to this one, because there was space inside of the enclosure. And to build this battery I'm going to spot weld nickel strips in place and do everything and explain everything when we go to this portion of the video. But just to quickly show you the construction and why it looks how it looks. So we have again we have our negative and positives over here. There is a piece of Kapton tape on top. This is just because I'm going to install it in a very tight enclosure, so that nothing that might come from either negative or positive from battery might be shorted over here. So this is just protection, but what's really necessary is that you protect this part over here, because we have main positive and main negative over here, and if something metal would fall on top it could short, because we have a very tight space from here to here, so you can easily short the whole battery pack, and that would be not really nice. And then we have our main positive tab on this side, just held in place with some painter's tape. Underneath this tab is not only the heat shrink for this from this cell, but also a piece of Kapton tape for additional safety. And then on this side we have the main negative, same goes over here, just a piece of painter's tape to hold it in place temporarily. And underneath we have a piece of Kapton tape which gets removed with the tape, so be careful. Yeah, so we have an additional layer of insulation between this tab and the battery. And on this side over here we have the center tab thing for balance charging, well, for balancing the cells. This is important for the BMS. Let me just quickly show you the BMS. This is this one over here. This is a 2S BMS. It's designed for a maximum continuous current of 8 amp and a burst current of 16 amp. Now, I'm not really planning to use that much right now. I have some calculations. Well, I don't actually know how much power the camera will use, and I don't actually know how much we will use over the USB, but the USB 5.2 volt 3 amp would be 15.6 watt of power from USB. Calculate in some losses and potential. Yeah, so essentially the low voltage of this kind of cell is 6 volt, and considering that this can deliver up to 8 amp, 6 times 8 is, quick maths, 48 watt maximum that I'm going to be able to pull at low voltage state. So I'm going to rate the whole project through all ports, USB and DC jacks, to not exceed, let's say, 35 watt of power. So whatever the camera uses minus what USB device uses will be left over for maybe something expansion in the future, like some portable lights or something. But this is all more in the future, but it's important that I'm actually sizing everything to use the maximum rated current of this device, which is really important for in terms of the cabling. So this just on the side. Cables will be sized like that. The battery is not really a problem. I mean, pulling 8 amps, we have a 4P configuration, so 4 cells in parallel. At 8 amps, each cell would be loaded with 2 amp. We actually have with these cells a 5P configuration, so it's even a bit lower, and that is totally fine. And this is only in low voltage state. In like the 8.4 volt state, with 40 or 35 watt of power, that is, what is that? Less than 5 amp. Let's just say it like this. Less than 5 amps, so this is totally fine. Now, the battery, oh yeah, I use battery holders, and these holders, very interesting. You get them in huge quantities like this, and you can just simply size the battery how you like or need. You have these pieces, you have these nubbins over here, you feed them in like this, and then you can, that is not really working, you can make your battery holder whatever size you desire or need. Now for these 2 cells, this is not what I'm going to do because we don't have enough space to do this, so I'm going to use some cardboard in between and stuff like that, but you'll see when we come to that. So this is the heart of the whole project, and I hope I didn't forget anything about this battery pack. Then I'm also going to install a battery charge indicator, one of these, which you simply hook up and then you see the state of charge. But as it doesn't make sense to have it powered on all the time because this consumes power, I'm also going to use some kind of a switch. But how I'm actually going to execute it, or actually this is something I did not prepare because I would like to have it over here, but everything needs to be inside for me to see if I have enough space, and you'll see in a moment when I'm going to place everything and then explain a bit more. So this is a charge indicator needing a switch so that I'm pressing a button like and see the state of charge. And now as for the charge port in the back, we have this one over here. If we take a look at the BMS has 5 connections. We have our battery middle, battery positive, battery minus. These are the ports that or pads that get connected to the battery pack. And these P plus and P minus are the protected outputs of the BMS. P plus and P minus are both for charging and discharging, which means through these ports over here I could charge the battery pack with the appropriate 8.4 volt, or as this BMS enables you to do, with a maximum 9 volts. So this actually drops a bit of voltage and allows you to charge with 9 volt. But the back port, so the port on the back side, will be connected to a buck converter over here. This buck converter enables me then to charge the battery pack with a voltage that is above like 10 volt, more like at 12 to 24 volt DC. So this enables me to have a wider range of charging voltages. And oh yeah, so this one, if I'm not mistaken, was rated for maximum 5 amp. Then we also need a few connectors. We have 2-pin connectors and this one over here, and I'll explain in a moment. So as you can see, everything, this is the very stiff bottom part of this enclosure. This is where I'm going to mount everything to. The problem is I have these ports on the top side, and if I ever need to disassemble it, I either have to make the cables long enough to be able to completely open it up, or that I can reach inside in some way and just disconnect everything so this comes apart. So this 2-pin connector over here is rated for 2 amp. This will be connected to the 2 USB ports. Now I know the USB board over here is rated for 3 amp, but I think these connectors would be fine for short time going for 3 amp. But in reality, most of the time I'm not going to use the full capability. But as for the main battery pack and these 3 outputs that will directly be connected to the BMS, that power camera and eventual future other things like lighting that have higher current, I have a slight problem. Every connector that I have is either for 2 amp or with this thing over here for 25 amp. So I don't have anything in between, so I'm going for these 25 amp battery connectors. They are a bit bulky and they have a downside, they easily come apart. Now there is this spring mechanism over here that holds it inside, and yeah, it's tight, but I'm going to use a zip tie anyway. This is what I typically do if I don't have to remove them. You can get a zip tie in between here and then simply close them off. So this will be inside of here, connecting these 3 ports, DC jacks, to the main battery